Module 9, Lesson 2 is on the vSphere HA architecture. After this lesson, you can describe the heartbeat mechanisms used by HA, identify and discuss other failure scenarios, and recognize vSphere HA design considerations. The vSphere HA architecture on agent communication. When ESXi hosts are put into a HA cluster, we have a fault domain manager. So all of this ends up in a fault domain. Then an election takes place to find a master and a slave. The master is elected as the ESXi host that can see the greatest or the more amount of data stores. If all the hosts have the same amount of data stores, then what happens, it then goes to another election process of the lowest management object ID from vCenter. So based on that, whichever ESXi host has the lowest management object ID is the one that becomes the master. And then what happens, we have our VPXA and host D that are running. The fault domain manager talks with these, but it's all the VPXA on each ESXi host, as you can see in this graphic in the green. They talk to the VPXD of the vCenter server, and then vCenter server determines how to manage it. As a backup, we also have, it'll put files, it'll be like host and then a number, let's say X, and some type of lock file you'll see on the data store. What'll happen then, that's a backup. If for some reason they can't communicate with each other, it'll look to the data stores as like a heartbeat. And I led into that with the data store heartbeats, network heartbeats. What'll happen, it sends this UDP signal to each other in the cluster, just letting them know, hey, I'm up, I'm still talking, the agents are good, everything's going on. After a certain time out, it can't respond to it. That's when it'll look at the data stores, and if it still can't, that's when it decides, hey, the agent's not running, so the host must not be running. And that's when it decides, hey, this host is offline. And again, as I just said in the last slide, it'll use the data store heartbeats with that lock file on each data store as a backup to where it can't talk over the network. Let's see, hey, we share these data stores. Is that file being updated by him? Is he still alive? You know, is he still up? All right, so we have some scenarios. Slave host failure, which is right here. So when a slave does not respond to the network heartbeat that's issued by the master, it tries to identify the cause. If it's a network, it'll turn around and try to look for the file locks in VMFS. And as you can see, it's got its primary heartbeat. It'll send an alternate network heartbeat. As we said in lesson 1, having redundant network heartbeats will help in this. If we can't communicate on one network, maybe that network's down, let's try another one. If we can't get to either one of them, let's look at the data stores as a means. What it's trying to do is any way it can communicate with the other host, it's going to try. Failed master host. If the master host is placed into maintenance mode or it dies, the slave host, and this could be multiple ones depending on how many you have in there, detects that the master is no longer issuing heartbeats. So what will happen then, we'll have a failed master host, as you can see here, and his management object ID is 99. So what will happen now, these guys talk to each other and say, hey, we don't have a master, let's elect a new one. So then let's just say, assuming in this scenario they see the same amount of data stores, so this guy will be the new master host and he'll get elected as the master, and he'll start sending out the heartbeats. An isolated host, if it does not receive any heartbeats or it doesn't see any election traffic, it can't ping itself, or its gateway is considered isolated. In design considerations, your host isolation, it can be minimized through a good design. You want to implement redundant network heartbeats and implement redundant isolation addresses. That way, if isolation did occur, it gives HA multiple ways to determine if the host is still alive. Also, implementing data stores that are separated from the management network. You could do it as using fiber channel over fiber optic, and you could physically separate your IP storage from the management network. So, say you're doing iSCSI or NFS IP storage, and you don't want that, which is good design to have that on its own network or on VLAN or something separate. You don't want to interfere with management traffic, but this is a great example. It's going to use management traffic to do the heartbeats. So having your IP storage on a different network, or even like it says here, fiber channel, completely separate, not even on the network, on its own little fiber fabric, it allows them all another way to communicate with each other. Now, virtual machine storage failures. You can have connectivity problems that can be due to a switch, misconfiguration of the array, or a power outage. Virtual machine availability is affected by the host. They can be difficult to manage, and you can have applications with attached disks that crash. And what this is saying is, we have a host that's lost access to his data store. Let's say this VM here is running. Well, if he's running an application that lives on this data store, of course the application can't run, but also this machine can't run if he's living on that data store. So you can see some problems with that. You'll eventually see it show up as unconnected, orphaned, until this storage device comes back up, or this path to that host on that storage. Which, if this were to happen, we should HA and it would reboot it on that host. But in a case where this become isolated, these two for some reason, then you would have this problem of this virtual machine would kind of be orphaned, because he doesn't know that he's down, and he doesn't know that he can boot him to him because they can't communicate. In an isolation example. A virtual machine component protection. This will protect against storage failures in a virtual machine. It runs on the HA cluster. You can only use this feature in an HA cluster that have ESXi 6 hosts, 6 or higher. You should now be able to describe the heartbeat mechanisms used by HA and identify the other failure scenarios and recognize HA design considerations.